Hello everyone. In this session, we are going to do all the questions of exercise 22A of the chapter Heights and Distances from the textbook Concise Mathematics by Selina Publications for class 10. So before solving the questions, let's first go through the concepts related to the exercise. Let us now understand what is angle of elevation. Let us consider that AB is a tower that is on a level ground and a man is standing at the point C on the level ground. So the line BC here is the horizontal line that is connecting the base of the tower and the man, and suppose this man is looking at the point A of the tower. So this becomes the line of sight. So the angle between the line of sight and the horizontal is called the angle of elevation. So here in this figure, angle ACB is the angle of elevation. Let us now understand what is angle of depression. Suppose a man is at point A and is viewing an object that is at C on the level ground. So the angle that is between the horizontal line here and the line of sight is called the angle of depression. The angle of depression in this figure will be angle EAC. Now, in this figure, if you look carefully, angle EAC, which is the angle of depression, will be equal to angle ACB, which is the angle of elevation. This is because the line AE and BC are horizontal lines, so they are parallel to each other, and the angle of depression and angle of elevation here are alternate interior angles, which are equal in the case of parallel lines. So this concept would be used even in the questions that we are going to do ahead. So let's now begin with the questions. The first question is, the height of a tree is √3 times the length of its shadow. Find the angle of elevation of the sun. So let us consider that this is the right angled triangle ABC, in which angle B is equal to 90 degree and BC is the shadow of the tree and AB is the tree. So we have to find the value of theta in this triangle. So we will consider, let X be the shadow of the tree. So according to the given question, the height of the tree is √3 times that of the shadow. So height of tree can be written as √3 times the shadow, which is X in this case. So we are going to write it as √3x now. So this becomes √3x. Now we have to calculate the value of theta here, and we know that tan theta is equal to height upon base. So here the height is √3x and the base BC is x. So x and x will get cancelled out and we have got √3 as the value of tan theta. Now we know that tan 60 degree is equal to √3. So from this, from A and B, we can conclude that therefore theta is equal to 60 degree. So hence we have found out the value of angle of elevation of the sun. The question 2 is, the angle of elevation of the top of a tower from a point on the ground and at a distance of 160 meter from its foot is found to be 60 degrees. Find the height of the tower. So let us consider that AB is a tower, B is the foot of the tower, C is a point on the ground, and the distance between the foot of the tower and the point on the ground is given as 160 meters. And it is also given that the angle of elevation, which is angle ACB, is given as 60 degrees. So we have to find the height of the tower. So let us consider that the height of the tower AB is h meters. So let h be the height of the tower. Then we are already given that angle ACB is given as 60 degrees. Now from the figure, we know that tan 60 degree, that is tan theta, is equal to height upon base. So here we are going to put the value in the formula. So h here we have to find out, and b here is given as 160 meter. And we know that the value of tan 60 degree is root 3. So we can find the height from here. This becomes 160 into root 3. Now we know the value of root 3, which is equal to 1.732. So we will put the value here, that is 1.732, and this will become 277.12 meter. So the height of the tower here in this question is equal to 277.12 meters. Question number 3 is, a ladder is placed along a wall such that its upper end is resting against a vertical wall. The foot of the ladder is 2.4 meter from the wall, and the ladder is making an angle of 68 degree with the ground. Find the height up to which the ladder reaches. So here we can consider that AB is the wall, BC is the ground, and AC is the ladder, and we have to find up to which height the ladder reaches on the wall, that is this height. So let us consider, let h be the height up to which the ladder reaches. The distance between the wall and the foot of the ladder is given as 2.4 meter, and we are going to consider angle ACB as 68 degree because the angle of elevation is given as 68 degrees. So from the figure, we know that tan theta is equal to height upon base. So here in this case, it will become tan 68 degree is equal to height upon base, which is equal to 2.4 meter. Now the value of tan 68 degree can be found out using the trigonometric tables of tan. So tan 68 degree is given as 2.475. So the value of height can be found out using by multiplying 2.475 with 2.4. So this is equal to 5.94 meters. So the ladder reaches up to a height of 5.94 meter. Question 4 is, two persons are standing on the opposite sides of a tower. They observe the angles of elevation of the top of the tower to be 30 degree and 38 degree respectively. Find the distance between them if the height of the tower is 50 meter. So let us consider that A and B are the two men. Then the angle of elevation from the first person is given as 30 degree, from the second person is given as 38 degree, and we have to calculate the distance between A and B. So that will be x plus y, and the height of the tower here is given as 50 meters. So let us first consider triangle PAQ. So in triangle PAQ, tan 30 degree will be equal to perpendicular upon base. So this will become 50 upon x. Now we know that the value of tan 30 degree is 1 by root 3. So we will substitute the value. So from this, the value of x that we have got is 50 root 3, and we know that the value of root 3 is 1.732. So we will multiply 50 with 1.732. So this will become 86.60 meters. So we have got the value of x. Now we will consider triangle PQB. So in triangle PQB, tan 38 degree is again equal to perpendicular upon base, which is equal to 50 upon y. The value of tan 38 degree from the trigonometric table can be found out. So that is equal to 0.7813. Now we will substitute the value here in place of tan 38 degree, and the value of y can be found out using 50 divided by 0.7813. On calculation, the value is approximately equal to 64 meters, and the distance between the two men can be now found out using x plus y, which is equal to 86.60 meter and 64 meter. So that is equal to 150.6 meters. Question number 5 is, a kite is attached to a string. Find the length of the string when the height of the kite is 60 meter and the string makes an angle 30 degree with the ground. So here let us assume that point A is the kite and AC is the string. So we have to calculate the value of AC as it is representing the length of the string. The height at which the kite is flying is 60 meters above the ground, and the angle of elevation in this case is equal to 30 degrees. So we have to calculate the value of L, and we are given this height. So from the figure we know that sine 30 degree is equal to perpendicular upon hypotenuse. So that will be equal to 60 upon L. Now we know that the value of sine 30 degree is 1 by 2. So this becomes 1 by 2 is equal to 60 by L. From this you can calculate the value of L. So this is 60 into 2. So the length of the string is 120 meters. Question number 6 is, a boy 1.6 meter tall is 20 meter away from a tower and observes the angle of elevation of the top of the tower to be 45 degree and 60 degree. Find the height of the tower in each case. So let us consider that AB is the tower and we have to find the height h. Then the distance between the tower and the boy is given as 20 meters. The height of the boy is given as 1.6 meter, and the angle of elevation formed when the boy is viewing at the top of the tower is theta, which is 45 degree in the first case and 60 degree in the second case. So now we will draw this line CP, which is parallel to the ground BD, and hence the value of BP is also equal to the height of the boy, that is 1.6 meter. So let us now consider the triangle APC. So in the first case, the value of theta is given as 45 degree. Now let us consider triangle APC. So we know that AP upon PC is equal to tan theta. Substituting the value, AP will be equal to H minus 1.6 meters. PC value is equal to the value of BD because these lines are horizontal lines and they are parallel to each other. So this becomes 20, and the value of tan theta will be equal to tan 45 degree, which is equal to 1. So from this equation, the value of H is 20 plus 1.6. So the height of the tower in the first case is equal to 21.6 meters. Now let us consider the angle when theta is equal to 60 degrees. And we will repeat the whole process. We will consider triangle APC, then AP upon PC is equal to tan theta. The value of AP is equal to H minus 1.6 meter. PC value is given as 20 meter, and the value of tan 60 is equal to root 3. So this becomes 20 root 3 plus 1.6. Now we know the value of root 3 is 1.732. So we will multiply 20 with that, and we will add 1.6 meters. So the final answer here will be equal to 36.24 meter. So the height of the tower in the second case will be equal to 36.24 meters. The question number 7 is, the upper part of a tree broken over by the wind makes an angle of 45 degrees with the ground, and the distance between the root to the point where the top of the tree touches the ground is 15 meters. What was the height of the tree before it was broken? So let us consider that the tree was standing here and then it broke, and this is the point where it broke, and then the top of the tree now is touching the ground here, forming an angle of 45 degrees. The distance between the root and the top of the tree is 15 meters, and we have to find out what was the height of the tree before it was broken. So that will be equal to h1 plus h2, because this is the part of the tree that has broken and is now touching the ground. That was also part of the height of the tree. So h2 plus h1 will give us the height of the tree before it was broken. So let us consider this triangle. So from this figure, we know that tan 45 degree is equal to h1 upon 15 meters. So this will give us the value of h1. Tan 45 degree we know that is equal to 1. So 1 will be multiplied with 15. h1 is equal to 15 meters. Now we know that sine 45 degree is equal to h1 upon h2, and the value of sine 45 degree is 1 by root 2. h1 value we have already found out, that is 15, and the value of h2 can be found out by rearranging it. So this becomes 15 into root 2. The value of root 2 is 1.414. So the value of 15 into 1.414 is equal to 21.21 meters. Now, to find the height of the tree before it was broken, we will add the values h1 plus h2. And this is equal to 15 plus 21.21 meters, and that is equal to 36.21 meters. So this is the answer of the question. The question number 8 is, the angle of elevation of the top of an unfinished tower at a point distance 80 meter from its base is 30 degrees. How much higher must the tower be raised so that its angle of elevation at the same point may be 60 degrees? So let us consider that the tower is made only till the point B. At this particular time, the angle of elevation that it is making with the ground at point D is 30 degrees. So we have to find out till what height the tower should be raised, that is, what should be the height of the point A, such that the angle of elevation that it is making still with the point D is 60 degrees now. The distance between C and D point is given as 80 meter. So let us consider in triangle BCD, we know that BC upon CD is equal to tan 30 degrees. So BC we have considered it as y, and the value of CD is given as 80, and this is equal to tan 30 degrees. Now we know that the value of tan 30 degrees is 1 by root 3. So the value of y is equal to 80 divided by root 3. Whenever we see the root signs in the denominator, we should first rationalize. So this would be rationalized, that is multiplied by root 3 and root 3 in the numerator and denominator. So this will become 80 by 80 root 3 by 3. This will reduce our time of doing the calculations and will be easier to calculate. Now we know that 80 divided by 3 is equal to 26.67, and the value of root 3 is 1.732. So this is equal to 46.19 meters. Now in the triangle ACD, the value of tan 60 degrees is equal to AC divided by CD. Tan 60 degrees is equal to root 3. The value of AC is equal to x plus y. So we will write it as x plus y divided by CD, that is equal to 80. The value of x here we have to calculate, and y we have already found out it as 46.19 meters. Now the value of root 3 is 1.732, so that is equal to 138.56. So the value of x, that is the height by which that unfinished tower must be raised, that is part AB length, is equal to 92.37 meter, which is the answer of this question. Question number 9 is, at a particular time when the sun's altitude is 30 degrees, the length of the shadow of a vertical tower is 45 meter. Calculate the height of the tower. Second, the length of the shadow of the same tower when the sun's altitude is 45 degrees and 60 degrees. So let us consider that AB is the tower and H be the height of the tower. BC is the length of the shadow, and the angle of the sun's altitude that is getting formed along with the ground, that is theta. So for the first part, we have to first calculate the length of the shadow. So in this triangle you can see that in triangle ABC, the value of tan theta is equal to H upon L. So tan theta here in the first case is given as 30 degrees. So this will become tan 30 degrees, which is equal to 1 by root 3. The value of H we have to calculate, and the length of shadow in the first case is given as 45 meters. So from this we will calculate the height of the tower, that is 45 divided by root 3. We will multiply both the numerator and denominator by root 3. So this becomes 45 root 3 divided by 3. We can cancel it out. So this becomes 15 root 3. The value of root 3 we all know, that is equal to 1.732. So 15 into 1.732, this is equal to 25.98 meters. So we have found the value of the height of the tower, that is 25.98 meters. For the first part of the calculation we are done. Now the second part is the length of the shadow of the same tower when the sun's altitude is 45 degrees. So here the value of theta is given as 45 degrees, and we have to calculate the length of the shadow. So from the triangle you can see tan theta is equal to h upon L. So value of theta is 45 degrees here, so tan 45 degree is equal to 1. Value of h we have already calculated, that is equal to 15 root 3, and the value of L we have to calculate. So the value of L here is again 15 root 3, which is equal to 25.98 meters. The second case is when the value of theta is equal to 60 degrees. So tan 60 degree is equal to root 3. Height of the tower we already have found out, that is 15 root 3. For now I'm not taking this value because root 3 will get cancelled out. So I'm just taking 15 root 3 now, and this is divided by L. So from this the value of L will be equal to 15 root 3 divided by root 3. Root 3 and root 3 will get cancelled out, and this is equal to 15 meters. So the height of the the length of the shadow in the second case would be equal to 15 meters. Question number 10 is, two vertical poles are on either side of a road. A 30-meter long ladder is placed between the two poles. When the ladder rests against one pole, it makes angle 32 degree 24 minute with the pole, and when it is turned to rest against another pole, it makes angle 32 degree 24 minute with the road. Calculate the width of the road. So let us consider that AB and CD are the two poles. BD here represents the width of the road. So when the ladder is placed at point P and it is resting against the first pole, then it makes an angle of 32 degree 24 minute with the pole. So this is the angle, and when it is turned to rest against another pole, that is the pole CD, then it is making 32 degree 24 minute with the road. So here now we will consider triangle ABP. So in triangle ABP, x divided by 30 is equal to sine 32 degree 24 minute. This is because sine theta is equal to perpendicular upon hypotenuse. Now the value of sine 32 degree 24 minute can be found out using the trigonometric table of sine, and this is equal to 0.536. So the value of x can be found out using 30 into 0.536. This is equal to 16.08 meters. Now we will consider triangle CPD. In this triangle, y upon 30 is equal to cos 32 degree 24 minute. The value of cos 32 degree 24 minute can be found out using the trigonometric table of cos. So this is equal to 0.844. Now the value of y is equal to 25.32 meters. So to find the width of the road, we will add the values of x and y from the equations A and B. So this will be equal to 16.08 plus 25.32, which is equal to 41.4 meters. The question number 11 is, two climbers are at points A and B on a vertical cliff face to an observer C 40 meter from the foot of the cliff on the level ground. A is at an elevation of 48 degree and B of 57 degree. So what is the distance between the climbers? So let us consider that A and B are the climbers. C is the point at which the observer is standing, and when he is looking at the point A, the angle of elevation is 48 degrees, and when he is looking at point B, the angle of elevation is 57 degree. The distance between the observer and the foot of the tower or the cliff is given as 40 meters, and we have to calculate the distance between the climbers. So let x be the distance between the climbers. So in this triangle BPC, the value of tan 57 degrees will be equal to PB upon PC, as tan theta is equal to perpendicular upon base. The value of PB right now we do not have it, so we will just write it as PB. PC is given as 40, and tan 57 degrees can be found out using the trigonometric tables of tan. So that is equal to 1.539. So the value of PB is equal to 61.57 meters. Now we will consider the triangle ACP. Again, tan 48 degrees will be equal to AP upon PC. Tan 48 degrees is equal to 1.110 from the trigonometric table of tangent, and the value of PC is given as 40, so that would be multiplied and we will get the answer of AP. So AP is equal to 44.4 meters. Now we have to calculate x here, that is equal to PB minus AP. So the value of x is equal to PB minus AP, and we have already calculated the values. This is equal to 61.57 minus 44.4. This is equal to 17.17 meters, and this is the answer of the question. Question number 12 is, a man stands 9 meters away from a flagpole. He observes that angle of elevation of the top of the pole is 28 degree and the angle of depression of the bottom of the pole is 13 degree. To calculate the height of the pole. So let us consider that AB is the man and PQ is the flagpole, and when the man is looking at the top point of the flagpole, the angle of elevation is 28 degree. The angle of elevation is always the angle between the line of sight and the horizontal line. So this is 28 degree, and the angle that is formed, angle of depression, when he is looking at the bottom of the pole, will be between the horizontal line and the line of sight, which is AQ in this case, that is given as 13 degrees. So we have to calculate the height of the pole. Height of the pole will be equal to PQ, and as we are splitting PQ into two parts, that is X and Y, we have to find X plus Y to get the value of PQ. The distance at which the man is standing away from the flagpole is given as 9 meters. So the distance between the man and the flagpole is 9 meters, and this horizontal line that we have drawn over here, which is equal to AR, also will be equal to 9 meters because these are horizontal lines which are parallel to each other. So let us now consider triangle PAR. So in triangle PAR, PR upon AR will be equal to tan 28 degree. We have assumed PR is equal to X and the value of AR is given as 9. Tan 28 degree value from the trigonometric table of tan is equal to 0.532. So the value of x is equal to 9 into 0.532, which is equal to 4.788 meters. Now we will consider the triangle ARQ. So in triangle ARQ, RQ upon AR is equal to tan 13 degree. RQ, we have already assumed it to be y. AR value is equal to 9 and tan 13 degree from the trigonometric table of tangent is equal to 0.231. The value of y is equal to 9 into 0.231, which is equal to 2.079 meters. Now we have to calculate the height of the pole. So height of the pole here is equal to x plus y, which is equal to 4.788, which we had already calculated, plus 2.079. Now this is equal to 6.867 meters. Question number 13 is, from the top of a cliff 92 meter high, the angle of depression of a buoy is 20 degrees. Calculate to the nearest meter the distance of the buoy from the foot of the cliff. So let us assume that AB is the cliff and C is the buoy, and the angle of depression, that is angle EAC, is given as 20 degrees. As we know that AE is a horizontal line like BC, so both these lines are parallel, and hence angle EAC, which is equal to the angle of depression, will be equal to angle ACB, which is equal to angle of elevation. So we have got the angle of elevation here. Now we have to calculate the distance of the buoy from the foot of the cliff. The foot of the cliff is point B, and we have to find the distance BC here, which is equal to y. So we will consider triangle ABC. Here AB upon BC is equal to tan 20 degrees. The value of AB is given as 92 meter. The value of BC, we have assumed it as y, and the value of tan 20 degree from the trigonometric table of tangent is equal to 0.3640. So now we will get the value of y from here as 92 divided by 0.3640, and this is equal to 252.7 meters. As we have to calculate it to the nearest meter, we will round it off, and this will become 253 meters, which is the answer of this question. Please do like this video and subscribe to the channel for more such videos.